Good morning, students. Today we are going to see with the topic effect of torque on rigid bodies. So, first let us see with the what is the formula for this torque, and for that let us consider a body which has non-zero external torque. That torque is denoted by tau, and it has the angular acceleration which is denoted by alpha. Okay, so the relation which relates this tau and this alpha is given by tau is equal to I into alpha, and here we know that I is the moment of inertia, and the torque, if it is in the rotational motion, it is also equivalent to the force in the linear motion. Okay, so if tau is the torque, we can say that tau is equal to the F, because it is in the rotational motion and this is in the linear motion. Clear? So this is the formula for tau. It is given by tau is equal to I into alpha. Clear? So next we are going to see with example 5.18. It says that a disk of mass 500 gram and radius 10 centimeter, it rotates about the fixed axis, and it has several turns. It is of mass 100 gram. Find the acceleration. So we are asked to find the acceleration of the body, and we are also given with the value of g. G is equal to 10 அப்படின்னு கொடுத்துருக்காங்க. We are given with the mass and the radius, and it is said that a disk of mass 500 gram and radius. So we are considering this to be the disk, and this has a mass which is 500 gram, and it has a radius which is 10 centimeter, and it can rotate about its fixed axis. So it has a fixed axis. Okay, and it is wound over several turns, and 100-gram body is suspended at its free end. So at its free end, another body which is of 100 gram, it has been suspended. So what are all given in this is m1 which is equal to 500 gram. So gram we are writing in kg, so it is 10 power minus 3 kg. Same way here also, gram 10 power minus 3 kg. 10 power minus 3 is divided by 1000. Okay, so this can be written as 0.5. Same way here also, divided by 1000, it is 0.1. Centimeter into meter, so it is into 10 power minus 2, so it is 0.1 meter. Clear? And now we are going to represent this question with the help of a diagram. Okay, so the diagram is, so this is a body. Okay, this is m1, so which is 500 gram, and this to be the radius. At its free end, another object, and that object has a 100 grams. Okay, so for this we are going to write the equation first using this. When we draw the free body diagram for the mass m1, okay, so this is the mass m1. This mass, whenever you consider any object, it has a normal force n, and downward it has a gravitational force which is given by mg. Here the mass is m1, so we are writing as m1 into g. Clear? And this object is tied to the other object, is it not? So whenever there is a string, there acts a tension. So here we are writing with a tension. So n m1g, that is what we have to know in this, and here we have the radius. Clear? So using this, if you write the equation, we'll get the equation to be m1 g is equal to m, because they both are in the opposite direction. So the equation can be written as m1 g is equal to n. Here we are saying that normal force which is acting upward and tension acting downwards, gravitational force and the normal force cancel each other because they are in the opposite direction. So we are writing it as m1 g is equal to n. Clear? So the tension T produces a torque. As we have seen that downward there is a tension, is it not? And because of that tension there is a torque. Okay, and it has an angular acceleration. Angular acceleration is denoted by A is equal to alpha is equal to A divided by R, because A is equal to R alpha into R. Okay, now if you want the value of alpha alone, we are bringing R down, so we are getting alpha is equal to A divided by R. Here if we represent moment of inertia to be I and the radius of gyration to be K, okay, then we can write this equation to be RT is equal to I into alpha. Okay, now substitute the values here. What is the value of I? I is given by m into k square, because this is the relation for radius of gyration. Okay, so I is equal to m into k square, then alpha is equal to what? A by R, so A divided by R. Okay, now have this T alone here, R we are bringing down. Okay, so we get m1 k square into a divided by r square. Then considering the second body, we have the body to be M2. That object has a tension T which is acting in the upward direction, and M2G. This is because of the gravitational force. Same way there is also a force because of this tension. Okay, that is denoted by M2 into A. Okay, so how can you write this is T which is acting upwards, then M2G which is acting up downwards minus M2A. So if you add all this, that is equal to 0. Okay, so this is equal to, yes. Now if you bring this terms to the other side, this can be written as T is equal to M2G, because minus, if you are bringing other side, that becomes plus. Same way this also plus M2 into A. Okay, among this bring M2 outside, so T is equal to M2 into G plus A. Okay, so these are the equations which you are considering using this diagram, because in this diagram we have three terms, which is tension T which is acting upward, then M2G and M2A which are acting in the downward direction. Okay, so this equation is M2G minus T is equal to M2A. So in the equation எடுத்துக்கிறோம். Now we are going to substitute the value of T. Okay, so T is equal to என்னது, this term fully. This is what we have considered from the first object. இல்லையா, இப்போ இந்த minus term இந்த side எடுத்துட்டு வந்துருங்க. Okay, so this becomes as plus. So M2, sorry, M1 into K square A divided by R square. Clear? Now among these two terms take A outside. Okay, so இதுலயும் A இருக்கு, இதுலயும் A இருக்கு. Okay, so among these two terms taking A outside, A common outside, so that we get m1 into k square by r square plus m2 into a. Okay, now we need the value of a alone, so bringing all these terms down. Okay, so we get m2 divided by m1 k square by r square plus m2 into g. Okay, so in this what we are going to do is we are going to substitute k square by r square is equal to 1. Why? Because this is the expression for this radius of gyration which is passing through the center perpendicular to the plane. The value is what? K square by r square is equal to 1 by 2. So k square by r square இடத்துல 1 by 2 அப்படின்னு போட்டா என்ன ஆயிடும் நம்மளுக்கு? In this equation k square by r square we are substituting as 1 by 2. So we are getting as m2 divided by 2. Okay, now take the LCM in this. So if we take the LCM here, we get m2 divided by m1 plus 2 m2 divided by 2 into g. Okay, same way bring 2 upward, so 2m2 divided by m1 plus 2m2 into g. So this gives the equation for the acceleration of the body. So this is the acceleration which we have found in this problem. So if we substitute the values in this m1, m2 and g. Okay, so if we solve this, we get the value of this acceleration. Thank you.